This is Ed Gastel. We're here at InteropNET in New York City, 2011, and just going to explain a little bit about the network here at InteropNET. Going to go through it once, look at it from an InteropNET perspective, and then we're going to go through it again and look at it from a traditional enterprise perspective. So we're going to use this as an example network really to give a better idea as to what an enterprise network looks like. So the first time through, look at it from how InteropNET is set up. So there's the internet that's connected through to these two co-location facilities in Denver and in Newark. There's multiple IPv4 and single IPv6 links out to the internet. From those co-location facilities that are also connected together by GigE links, we have GigE WAN links coming down here. So everything from this bottom part of the screen is here in New York City at the convention center. So when these GigE WAN links first come in through the WAN provider, they immediately go through a firewall that protects everything down here from hackers from the outside world. So the link facing Denver after the firewall gets terminated into a Cisco core router that we'll look at here in a little bit. From Newark, it gets terminated into an HP core router. Those core routers are connected together by multiple 10 gig links so that traffic can flow across them. From HP manages what's called the off-show floor, so all the speaking rooms, all the presentation rooms, media rooms, things of that nature. So from that HP core router, it goes off into these access switches. And just down here, I've drawn an example that from one access switch, we would go out to multiple devices. So this could be a speaker's laptop, for example, in one of the training rooms. The Cisco feeds all the show floor, so all the booths that are out in this show, they have gigabit Ethernet links dropped to them. So from that Cisco core switch, there are 10 gig Ethernet links going out to all the access switches, and then from the access switches, we have 1 gig links going out to all the booths, which are the clients are terminated there. These 10 gig links here in New York, these are all copper-based links. So that's kind of what InteropNET looks like. And now we're just going to do the same thing, but we're going to look at it more from a traditional enterprise. What would that look like? Because this is going to be the office in a traditional enterprise. So you've got the internet, you've got these facilities here in a traditional enterprise network. These could be your data centers, and you could find within them storage area networks could be within those facilities. So you could have all your storage in these places. So those data centers are going to then get connected through WAN links and could be very easily GigE WAN links down into the office building. So this is really what you're going to find in an office building in most cases where you don't have a data center. You're going to see multiple core routers, and it could be that this is one building, this is another building in a campus environment, and then these access switches are most likely going to be individual floors within that office space. So from your core router, you're going to have these riser cables that are going up to the various floors, so floor 1, 2, 3, 4, 5 kind of idea, and then within each individual floor, you would feed off into all the workstations of all the people that work on that floor. So, 48 port switch going to feed 48 different workstations on that floor. So that's really what it looks like from a traditional enterprise perspective. So now what we're going to do is we're going to go out and we're going to look at what these actually look like in real life. So here we are at the firewall. This pedestal or this rack here is the firewall. So you can see down here the two links coming in from Newark and coming in from Denver feed into these switches, which then have VLANs across into the firewall. And then these links then will go off to the HP and to the Cisco core devices. So right next to the firewall, we have the HP core racks. And you can see there's many things. There's some F5 for some security. There's a Gigamon for some tapping. We actually have a tap off the Gigamon so that we can monitor traffic. But here's the HP core router. There's 2 of them that are connected together, 2 for redundancy, pretty typical of core routing. Because we only have 1 gigabit Ethernet link that comes into these core devices, the other one goes into the Cisco. You can see that that connects right in here to the first rack, the externals. So those are the WAN links coming in. This is everything. You take this off, there's no connection now to the outside world. And then from here inside of the router, you've got these multiple subnets that are feeding off into each of the individual access switches, and the access switches will then feed out into the individual workstations. In this case at Interop, it's feeding off into the individual classrooms. And that's essentially what a core router is going to do, is just aggregating. You're bringing in your outside links, and then you're feeding them off into all your distribution and access devices so that you can just break down and down and down and down until you get to an individual desktop. So here we are at the Cisco core router. There's two of them for redundancy, whereas HP had two separate racks. We've now got two completely duplicate routers, but in the same rack. Different power systems, but it's for redundancy. But just as with the HP, we've got a single external interface comes in. This is facing the Denver location, so this would be one of the two WAN links that would be into an enterprise. It's actually connected through some ribbon fibers that are up here that really not going to go through that too much. So this comes into the router, and then we want to feed off into 5 individual distribution or access switches. In this case, you're doing that by 10 gig links. So each one of these cables on this Cisco blade, these are 10 gig over copper, so 10 G base T links. It's a 16 port device. Each one is its own individual IP subnet, and again, redundancy, so the blue and the yellow. So in order to serve out to all the distribution or access switches, there's a blade in here in the Cisco router that's got 16 10G base T ports on it. We're only using 5, so really underutilizing the capacity of this router in this particular situation. But you could think of this as serving 16 different floors of an office building. So again, 10G base T links are going off. You've got the blue cables as the primary, you got yellows as a secondary, so that from the core routers, you've got duplicate links going off into each of the individual access racks, so that if something were to happen to this blade or to this router, then you'd have another one. Each one of these individual ports represents a specific IP subnet or more, because there's VLAN trunking on each of these cables as well. So multiple IP subnets on each cord and 16 different individual connections that you could have. So what we're going to do now is we're going to look at how these cables that are terminated in the front of the device end up getting all the way out to the individual devices, the individual switching locations, the distribution and access switches. And for that, we need to go to the back of the rack. Okay, so here we are at the back of the rack, and you can see all the cables coming out to the back. So this is the blue and the yellow, that's your main and your secondary along here. And then from here, this is a structured cable system. This could be horizontal or it could be a riser type cable. So 10 gig links, the category 6A cables, they come into the back of a patch panel, or sorry, into the front of the patch panel, and then on the back of the patch panel, everything's punched down, and then the cables will run out up to 100 meters, and you can see them kind of going up, in this case, and off, but this would be in a typical office environment. Those cables, those horizontal cables, would then go out and they would terminate into each of the individual racks that's going to be for the access switches. Those Cat6A cables are now coming into this rack, which is an access rack that's going to serve individual workstations. So that comes in, and it comes to the back of the patch panel. So it's a mirror image exactly of what we saw before, but now instead of having 5, we've only got 1, because there's 5 racks like this in this particular network. There could be, as we saw with a 16-port switch, there could be up to 16. So on the back side, we've got our cables plugged in, punched down onto the back. Now we've got our patch panels that are going to go to the front and plug into our access switches. So here we have, as we saw on the back, there's the blue cable for primary, the yellow for secondary, 10 gig E-links that are going through all those patch panels, all that cabling, and eventually you're plugging into that blade on the Cisco switch that we looked at earlier. So we've got an individual subnet coming in to this rack. Then from these 10 gig links, where we have in the uplink ports, we then have on each switch 48 ports of 10 100 gig Ethernet that needs to eventually get out to an individual workstation, or here at InteropNET out to an individual booth. The way that it does that is through these patch cords that connect from the switch itself up through to a patch panel, which is typically at the top of the rack. So here at the patch panel, what we have is we're plugged into the front of the patch panel from the switch, and then on the back of the patch panel we have all of our horizontal cabling. Now, instead of being Cat 6A like our 10 gig needed to be, these are Cat 5e cables that are going out and are serving individual workstations. So if you think of yourself sitting at a desk and you've got an RJ45 outlet next to it, you're eventually going to be connected through all this horizontal cable, through a patch cord, into the switch, through the 10 gig links, back to the core device, and then up through the WAN links that we saw to the internet. So what we just saw was the access switch, and from the access switch through patch cords into a patch panel, and then across the horizontal cable. Here at InteropNET, that terminates into this RJ45 that when the people come into their booths, they can plug this into their PC directly and they have access to the internet. In a normal enterprise network, what that would be is the RJ45 wall plate that would be at your booth, be in the conference room, be in your cubicle, those types of things that you'd plug a patch cord into and then connect it into your computer to give you access to the network. So what we've seen here throughout all these things, take it from this location here at the very end, it's going to be into a computer, through all the cabling, horizontal cabling, patch cabling, into an access switch, from the access switch across the higher speed links, in this case 10 gig links, into a core or distribution router, and then from there you have your links to your external devices. So that could be data centers, it could be the internet, it could be another office, all those types of things. So that gives you an overall good picture of what an enterprise looks like, all the way from the computer throughout into the internet.